All right, welcome to the vBrownbag session. Today I'm going to be talking about offloading VXLAN to the top of rack switches. My name is Madhu Kashyap. I'm the Senior Product Manager for OpenStack at Brocade. And with me is Ritesh Madapurath, who's the Senior Software Engineer. Talk about the basic topology of how VXLAN runs today, where you can automate it through Open vSwitch. And then we talk about offloading that to the top of rack switches, again using OpenStack, and we show you a demo of how that's done and automated through OpenStack. So this is your basic topology. You have your software VTEPs running on the VMs. You have your top of rack switches. You have a leaf and spine architecture. And the Brocade VDX switches acts as the top of rack switch both on the leaf and the spine. And today you can do that using OpenStack and using the OpenStack orchestration to create these different tunnels on the OVS. Okay, so the software VTEPs on the OVS, the leaf and spine switches act as a pass-through, basically. But then there is an overhead on the OVS, and the OVS is really limited by the hardware or the compute hardware where it's running. So whether it's CPU, memory, your NIC card, that's the line rate you get. That's the rate you get for on the OVS when you have your tunnels terminating on the logical switches. So what we're going to demonstrate is creating a IP fabric, which is your leaf and spine switches. We'll create the tunnels between the top of rack switches, so when a tenant comes in and instantiates a VM on different racks, and automatically a tunnel is created on the top of rack switches. And all this, you get the performance benefits when the tunnels are on the top of rack switches. You get the hardware acceleration and the line rate from the switches. And all this is integrated through OpenStack. And we'll show you the way the tunnels are created, and then the mapping and the removal of the tunnels when the virtual machines go away. So this is the demo, automation of the underlay, provisioning a whole IP fabric, setting up the tunnels when tenants come on, and then the dismantling of the tunnels, and also a part of the demo where we disable a particular link, and we have no packet loss, and the tunnel is still up and running. So with that, I'm going to hand over to Ritesh, and he'll take you through the demo. Thank you.
Hello. So this is a topology we have. This is a topology. We have a spine leaf topology. Now, first, what you're going to start off is the automation of the underlay network. We have an auto discovery which will go and discover the spine and the leaf, and auto provision the link addresses, auto provision the R bridge IDs, and auto provision even the BGP IP routes. So there is no manual configuration required here. So the entire underlay network is auto provision. So what you see here are two leaf nodes at the bottom and the two on the top. So what I'm trying to show here is that I'm doing an IP route to show that nothing is actually configured, everything is clean. Yeah. So now I'll go over to the OpenStack Horizon dashboard and then show you the new tabs which we have added depicting the underlay and the overlay. So here as well you will see that there is nothing really configured. So we are starting clean. Now what I go and do is I go and kickstart the OpenStack Neutron process. Here the discovery of the spine and the leaf starts. We go and, as I mentioned earlier, I go and configure the IP links between the spine and the leaf, and also go and configure the BGP IP routes. So as the configuration is happening, as the discovery is happening, you would see that the IP routes can be seen on the leaf nodes. The 90 subnet is used for the VTEP IP, and the 54 is used for the link IP addresses. So as the discovery is happening, as we do a subsequent do show IP routes, you would see that on the leaf node on the left hand side there is ECMP path, the two paths, because one leaf is connected to two spines. Similarly on the right hand side as well, you would see that there are two paths available between the leaf and the spines. which is typical of a spine leaf topology, and we are having IBGP running between the leaf and the spine for distributing the routes. Now what I would go ahead and do is that I'll go to the horizon dashboard and show the spine leaf topology which you have discovered. This is typically indicating how the spine and the leaf have interconnected and what are the configuration IP addresses which you are using. These are the overlay gateway IP addresses. So we have finished the automation of the underlay. Now we go for the automation of the overlay. A VM appearing on one of the racks, there's another VM appearing on another rack. They are part of the same broadcast domain. So we create the tunnel between the two VMs, between the top of the rack switches. So again, to start with, I'm showing that there is no tunnel between the two top of the rack switches. So we are all set ready. Our underlay is automated, so we are going for the automation of the overlay. So what I do is that I go and create a network. This is the network which will be used for the overlay. Here I'm creating a network called demo, creating a subnet, demo subnet, and using 14.14.14.0 sub IP address for the subnet. So all our VMs are going to get created on this particular subnet. So now we have the network created. So now what we are going to do is that we are going to create a tunnel. The first step for the creation of the tunnel, that is the first creating a VM on one of the racks. So the requirement here is that the VM has to be, there has to be two VMs on two racks, and they have to be part of the same broadcast domain. Only then we establish the tunnel. So the setup and the dismantling is actually controlled within the OpenStack environment. So I've created the first VM. The VM has got created on one of the racks. So now if I go back and look at the leaf nodes, you would not see the tunnel created because there is only one VM. So the VM is getting spawned. So here, if you execute the tunnels, there are no tunnels created between the top of the rack. Now I go ahead and create the second VM. So this again will pick up one of the IP addresses from the subnet which I've configured for the demo network. And so yeah, we are picking up the demo network. So the second VM is getting spawned. So now the thing is that in the second VM is on the second rack and it's on the same broadcast domain, we would establish a tunnel between them and we would do the auto mapping between the VLAN and the VNI. So now since the VM has got established, we will start the launch the console of the two VMs. And what we are going to try to show here is that we are going to ping between the VM launch on first rack to the VM launch on the second rack, indicating that the path is established between the two leaf nodes and the cross network is really working. So I'm logging onto the first VM. You would see that it has taken one of the IP addresses from the 14 subnet. I log on to the second VM. It also has picked up one of the IP addresses from the 14.14.14 subnet. And now what I'm going to do is I'm going to kickstart the ping between the two VMs. So you would see that the ping has started. We'll now verify from our network that the ping is effective, and as you could see with the tunnel statistics, the numbers are increasing from 160 and 173, clearly indicating that the packet has transited through the leaf nodes on the clause. So the next thing which we would like to show here is the tunnels from the overlay. So here we show that the tunnels have got created between the two top of the racks. The next part of the demo is on the L3 ECMP. What we want to show here is basically we have an ECMP setup between the two devices, between the two leaf nodes. So what I'm going to do here is actually shut one of the interfaces and show that the ECMP path gets destroyed. So here I do a shut, and you would see that on the right hand side there were two paths. The ping has momentarily stopped, and it would it will just kickstart now. So the convergence has happened, and then we do a, if you come back here, we see that the IP routes, we have the two ECMPs. So since one of the link has gone down, if you do a do show IP route, you would see that now there is only one IP route to the other leaf node. So if you now revert back the interface, do a no shut, we would get back the IP route. So this clearly shows that we are able to automate both the underlay as well as the overlay from OpenStack. And the beauty about this is that there is hardly any manual configuration required. Everything is automated through within OpenStack. Thank you.
Thank you.